So in the previous section there, we were looking at combinations in terms of permutations with repeating elements, and then order didn't matter. So if we formalize our combinations, what we're looking at is permutations, order matters. Combinations, the order we select items does not matter. Formulaically, we'll see the N combinations R button on your calculator. You might also see it in one of two other ways. One is similar to the permutations notation with the brackets, like this. The other way you might see it is in brackets with the N stacked over the R. Both of these are other ways you may see combinations noted. In terms of factorial, N factorial over N minus R factorial times R factorial. Again, N is the total number of items we have to choose from, and then R is the number of items we are choosing. So if we look at that in terms of some examples, we got a fast food restaurant has 10 items on its value menu. How many ways can somebody choose 3 items off the value menu? Well, we have 10 items, we're going to choose 3. So as a factorial, 10 factorial over 10 minus 3 factorial times 3 factorial. So breaking this down, 10 times 9 times 8 times 7 factorial. And I'm stopping at 7 factorial because 10 minus 3 is going to be 7 factorial. Those will cancel. Then I have 3 times 2 times 1. The 7 factorials will cancel. 3 and 9, that leaves a 3. 2 and 8, it's going to leave a 4. So I got 10 times 3 times 4. That's going to tally up to 120 different possible combinations of choosing 3 items off the value menu. Again, you could also just press the NCR button. So 10 NCR 3 on your calculator, you should get the same result. Another example here. In this case, we have a multiple groups that we're choosing. So a class is selecting 4 boys and 4 girls to represent it in a school competition. So we're selecting 4 boys and 4 girls. So we have multiple groups that we need to select from. If there are 13 boys and 12 girls in the class, how many ways can the team be selected? So we have 13 boys. We're going to choose 4 of them. And then, unlike OR questions, or where we were adding them, this is an AND question. So the ways we can arrange all the boys times each possible arrangement of girls, which is 12, choose 4. Okay, so because we have multiple groups, we multiply the arrangements of each individual group together. So we have 13, choose 4. Which is 715 times 12, choose 4, which is 495. And when we multiply those guys together, the number of combinations of 4 boys and 4 girls to represent the class is 353,925. And yes, we will get many big numbers when we're working with combinations and permutations. So again, combinations, the NCR, we're choosing. So we have N items, we're choosing our items. If you have multiple groups, you're multiplying each of the combinations together.